All right, guys, this is the 2019 AB exam question number 3, and this one is a pretty tough question overall. You're given the graph of f right here, and in the directions you're told that f is defined on the closed interval from -6 to 5. So some of the graph is missing, right? Like we know from -6 to 2, it's something, we just don't know what it is, so keep that in mind. It gives you a coordinate of 3 comma 3 minus root 5, and it tells you that this curve right here is a quarter of a circle. Okay, in part A it tells you that the integration from -6 to 5 is 7, and then wants you to find the value of the integration from -6 to -2. All right, so again it says that the integration from -6 to 5 is 7. So I don't know what's going on from -6 to -2, but I do know that if I find the area from -6 all the way to 5, then it's going to be equal to 7. So what I can do is set up an equation that says, well, 7, all of it, is equal to the part of the graph that I don't see plus the part of the graph that I do see. And if I can figure out the area of the part of the graph that I can see, and then subtract it from the total area, I'll be left with what they're asking for. All right, so I'm starting thinking about my area at -2. So that little triangle counts positive, that little triangle counts negative, that little bitty triangle counts negative. And if you're having a hard time, like how did I know that that was crossing the x-axis at 1/2 right there, based on my calculations? It's just because that's on a straight line that has a slope of 4/2, and you can think about it that way, okay? Then I'm picking up here, and so like this triangle right here is gonna count positive, and that's the end of my blue, all right? So fine. Now I've gotta also figure out the area under that curve right there. So if you think about it, if I do this, okay, and I think about, well, I just want the area here, okay? Well, that area can be found by saying, well, the area of the entire basically square that I've made in black, subtract away the stuff above the curve that I don't want. Well, that entire square right there is a 3 by 3, and then I can subtract away the stuff that I don't want right here, and I know that it's a quarter of a circle with a radius of 3 because it told it to me. So there's my 9 minus the quarter of the circle piece. All right. Do your arithmetic. You get a value out, and then you subtract that from 7, and that leaves you with what -6 to -2 is. And the final answer should be 9 pi over 4 minus 4. Part B. Evaluate from 3 to 5, 2f prime, the integration of 2f prime plus 4. That's super easy. F prime integrates to f. 4 is going to integrate to 4x. And then just plug and chug. Don't forget that's the graph of f. So that's how I'm figuring out like what the values are, right? Like f of 5 is 0. And later on in there, I got to plug a 3, and f of 3 is equal to 3 minus roots of 5. That's what they told it to you. Part C, g is given by the integration of f. Find the absolute max of g on the closed interval from -2 to 5 and justify. You're looking for an absolute extreme on a closed interval. Check your endpoints and when the derivative is 0. Okay, there's my endpoints. All right, and then my derivative is equal to 0, obviously at -1 and at 1/2. Okay. I found all these outputs along the way in part A, so it was just a matter of organizing them in a table and then picking the biggest output. You think about that right there, it's about 28 divided by 4, so that's pretty much 11 minus 7, which is way bigger than the rest of the outputs in the table, so he's the max. And then in part D, find the limit as x approaches 1 of that foolishness right there. And it looks scary at first glance, but just start plugging a 1 in and see what happens, right? So like 10 to the first is 10, 3 is 3, f prime of 1, well, that's just the slope of f, right? And the slope of this graph right here is consistent. So at 1, or really at every point on that line right there, your slope is 2. So that was pretty easy. F of 1, well, that's the graph of f, right? And f of 1 is 1. That's pretty obvious. And then minus arctan of 1. Arctan means whose angle has that tangent value. So arctan of 1, be thinking, all right, well, tangent is sine divided by cosine. And when is sine divided by cosine equal to 1? Well, when sine and cosine are the same thing. And they're first the same thing at pi over 4. All right, so that's why that's a pi over 4. Anytime you're ever asked about arc trig, arc sine, arc cosine, arc tangent, whatever, it means whose angle has that trig value, and you pick the first angle as you open in the positive direction. All right.